Hi everyone, François Baillargeon here. I'm a system administrator from Quebec City, Canada. Today I'm going to show you the recipe to get out of the VMware environment. Why would you want to do that? Well, I don't know if you guys are into the news right now, but lots of organizations are finding out that their renewals are going to be really expensive, reaching $10,000, $12,000 Canadian per server on an average 32 core run-of-the-mill Dell or whatever server. This is beyond the reach of most small businesses in Canada and Quebec. Also, like non-profits, they cannot afford that. So it's kind of a crisis in the virtualization world right now, but there's a way out. I'm going to show you that today, how to do it. I'm going to be using software from Proxmox and software from Croit. Proxmox is a generalized virtualization platform that's competing with VMware. It can run all the same things. And Croit is just a nice way to administer Ceph clusters. You will be asking rightfully, why am I not doing hyperconverged deployment? Basically because hyperconverged deployments are more complicated to administer long run because done through it, compute, the network are going to be fighting within themselves because they're co-hosted, so it's harder to administer, and it also suffers from the noisy neighbors problem. Imagine here, a CPU is getting pegged by a large VM running, I don't know what, transcoding, SQL, something like that. This is going to be tanking your IO for everything else. So how we do it today, we're going to be using Croit to administer a completely separate Ceph instance, and we're just gonna mix that together, and it's gonna be much easier to administer. And beyond that, if you need a hand with any of this, you can absolutely call me, DM me, email me. Let's have a chat about your environment. It's completely free, no obligation on your part, obviously. We're just gonna have a chat about the sizing of what you have, the kind of challenges that you have, the kind of preparators you have, everything in between. I mean, we've been doing conversions from VMware to Proxmox for the past, I don't know how many years at this point, but we can absolutely be of help in your environment and make sure that you have a smooth transition. We're just gonna start our unit with start in container. The prerequisite for that is just your run-of-the-mill Ubuntu or Linux machine running Docker, and from that we're gonna start a container. We're gonna deploy your environment, and you're gonna see it's extremely easy to get started. First step, we're gonna connect to our management server. I'm gonna use SSH here to do that. All right. Putting in the password. All right, we're in. So first step, I'm gonna start a container from instructions found on the website from Croit. No proxy, no HTTPS proxy, container starting. Usually takes like a minute. We're in a virtual environment, so it's kind of slower, but you know, it's just to give an example at this point. It's still fast, you know. The container is pretty lightweight, so it starts in minutes. So we're just gonna give it a little time. All right, it's starting, almost there. All right, perfect. We have the password. We're gonna log into our web interface at the IP we had as an admin. All right, so I'm admin. I'm gonna put in the password. If ever you lose it, they're in the Docker logs, by the way, so no worries about that. We need to put a strong password. It's a law requirement in the EU, but also a smart move on our end. So we change the password. All right, we're in. We're gonna accept the EULA, pretty simple. Also available in German if that's your native language. We're gonna set up the network first. Please be aware that this is gonna be running DHCP and TFTP. So don't run that in a VLAN that there's already something on it. So this will be running the whole coordinator container, like I said, running DHCP, and it's going to be pushing the TFTP server images to the server so they can boot. Everything is ephemeral, so if ever something misbehaves, you can just reboot your server. So no errors. All right, we're gonna start the servers now. Bear in mind these are virtual because it's a development environment and it's just show you guys, and we don't have enough hardware to do it on real hardware, but you see it's booting, got an image from the background. Dynamically it just boots. You have a menu for diagnostics and everything. So it's all in memory. It just boots. All right, so we can see Alza Linux booting up. Nothing weird in the logs at this point. That's great. Yeah, it's behaving just like it should. Though, yeah, I cannot do power state because it's a virtual machine, but nobody really cares at this point. It's just to show. So you can see all my servers are detected and booted. So I'm gonna call them host 1 Ceph, host 2 Ceph, and also host 3 Ceph. All right. Okay, next step, we're gonna deploy the mons. We have to have odd numbers because questions of quorums. I already made small disks as SSDs in the virtual environment. One of the disks is gonna be the storage disk. The others are gonna be the mon disks. So all right, they're gonna be coordinating all the servers between themselves. All right, they're creating no errors yet. I'm just probably all right. Yeah, I'm gonna look at the logs, making sure everything's fine. Okay, everything was fine. We're started. This is a good sign. All right. Monitors takes a little while, but it's super fast usually. It's pretty fast, and these are pretty light services. All right, from the logs, everything was fine. He tested this. Everything is cool. Partitions are made. All right, we're up. Yep, they're getting added to the crash map that determines how data placement is on your cluster. That's awesome. I guess we're up. Everything seems fine, at least from what I can see. All right. Okay, putting all the default values. Yep, yep, it's looking real good here. Like half the work's already there, people, for the... I'm just gonna take all the remaining disks. These are gonna be rolled as object storage daemons, also known as OSDs. This is where stuff your data. We're gonna collocate the database in the wired head log because it's simpler in a dev environment. Usually in a real world scenario, you would be putting hard drives with DB walls so you can have a write layer that's going to be faster. If you have especially rotating disks such as SSDs, sorry, I mean HDDs. So we do it a little quicker because it's a demo. Yeah, I have a clock skew error, but not super worried. In virtual environment, it's hard to have super tight tolerances like that. So, but it doesn't really matter. All right. So yeah, I have a health warning, but everything else is fine. You have all the mons up, the OSDs are up. Yeah, it still says no OSDs, but it's gonna refresh soon. All right. So first thing first, we're gonna be creating a pool. The pool is really the basic entity to store your data on a Ceph cluster. This is where the virtual images are gonna be living. I'm just gonna validate the crash rule. It says, yeah, all hosts have different rules for as far as they're going to be distributing data, but that's great. So we're creating a pool right now. I'm just going to edit the default values of the manager pool. So it takes the SSDs and it's faster. All right, we're going to close that. And then I'm going to create the pool itself for our data. We're going to give it a significant name. We're not using erasure coding because we don't have any nodes. To do that, usually need like more than 6. All right, so it's going to be the RBD pool. It's going to be the RBD pool for Proxmox. All right. I'm going to give it 128 placement groups. It's going to be a Rados block device, which is basically a big virtual disk library. So Proxmox will be able to store its virtual machine's images on there. All right. So next step. All right, we have 3 OSDs, 3 mons, 3 servers, utilizations at 0. Yeah, still have the clock skew, but I think it's gonna go away at some point. Doesn't really matter. It's a demo, but you know, in a real environment. Oh, there it is. It fixed the clock skew. The NTP client probably just did that. All right. So next step, we're gonna be creating a key. All right. So what does the key does? It just gives it an access for the Proxmox cluster to be able to consume RBD images. So we're gonna call it client.proxmox has access to all RBD pools. It's going to be a read write because obviously you want your RBDs to be writable if you're going to be doing anything serious. And to be honest, they don't boot if you don't have write enabled. All right, so yep, I can see that some space is consumed probably to create the containers and file systems and all that jazz, but beyond that, everything is pretty okay. I'm just gonna check the compression settings. Usually giving passive LZ4 just gives a little edge if you store data that's compressible. And especially with modern CPUs, you usually get speed improvements because it decompresses and compresses so fast that you usually write less to the disk, so it improves both throughput and latency. So, all right. Okay, next step, we're gonna be installing Proxmox itself. We're gonna be installing 3 nodes of these things. These are virtual, obviously, so it's nested virtualization. I'm gonna start from the CD-ROM. Well, CD-ROM. That shows my age. I mean the virtual DVD. But the Ceph layer is already up and running, so it can give you disk access to store your machines. So, alright, we're starting the installation. So I agree to the EULA. I install on the virtual disk, that's fine. So I'm just gonna give it a country. I'm Canadian. I'm gonna pick a time zone. Alright. No, not a Ticoban, it's not me. Oh, and also there's Dawson's Creek for fans of the show, but I'm gonna say I'm in Toronto because I'm on the Eastern Daylight Time at the time of making this video. The layout, keep it English, so that I'm gonna go fishing for accent and stuff like that. I'm gonna give it a strong password. All right. I'm gonna confirm my super strong password also. All right. I'm gonna give it my own email so I can get alerts and stuff like that down the road. But all right. I can see my DHCP server already found local values. So you have a valid IP, that's fine. I'm noticing because I do it cross-prod that the gateway is iffy. I'm just gonna modify that later on, but it's a small thing and it's gonna show you how to edit things in post-prod. All right, so we're gonna next on that. So it's gonna be installing. So even though it's a virtual environment, it's gonna take like 2 minutes at most. So it's very simple. I mean, that's already there is to it to start a single node. Obviously, we're going to do many more nodes. We're going to do 3. So we have an odd number of nodes. Same principle as the Ceph cluster. We want to have odd numbers so we don't have split brain scenarios. But you're going to see it's extremely easy to be able to install everything. So, all right, it's almost installed. All the last debs. We're at 70%. And yeah, the thing is with split brain, you need to have more than half of the nodes that are healthy because they do an election of who's right about writing and virtual machine status and things like that. So we're going to show you how to do it production ready-ish from day one. So you don't have to play with it again. I mean, you could have only 2 machines, but then you would need a quorum device and that needs to be ran as a third device. So people usually just shell out for a third server. No worries. All right, so almost done, guys. Make the system bootable. All right, writing to grub and all that jazz. And we're going to be rebooting. All right, and it says that it's available at the system IP port 8006 on HTTPS in your browser. So it's booting, and please notice I'm using DHCP addresses. In production, you wouldn't be doing that. You would probably give it a fixed address because, you know, what if the HTTP runs on the cluster itself? You're gonna have issues. So it's booting from the first partition, and there we are. We already have access to the machine. So if I log into it, let's see, and here we go. I'm logging his root with the password I set up previously. Yeah, I don't have a subscription because we're doing development work. That's fine. So everything is up. All right, the network. I'm just gonna edit what I said I would. First interface, I'm gonna give it a nice gateway because it's gonna be wanting to reach the internet for updates and stuff like that. So, and bear in mind, I'm running on the bridge because I have limited interfaces in the virtual environment, but I would probably put it as VLAN aware bridge without any IP and give it a dedicated interface as far as management. But remind guys, it's just a demo, so I'm not following all the best practices. So I'm already going to be creating networks for CoreSync. What does CoreSync do in life? Is the way to keep everything synchronized between your cluster. So, oh, sorry, I'm editing the storage layer at this point, sorry. All right, so as I was saying, I'm going to be creating CoreSync. So CoreSync requires different addresses. Usually, it's a good idea not for them to reach each other through a router. It's really a level 2 system. No need to route anything. So I'm gonna say CoreSync 1. All right, yeah, I do need to give it a cider. It's gonna be /24 for simplicity, but whatever floats your boat. As long as each node can reach each node. All right, so I set up my second. Make sure the auto start CoreSync 2. All right, so it's gonna be network 30. All right, so everybody here is both. I'm gonna apply everything. Okay, they're active, they're up. That's a good thing. They just reloaded the configuration. And as you see, I already installed my other nodes, so I'm gonna do the same gig here. I didn't show installing the other nodes, but all right, this guy already has the right gateway. So here we go again. We're gonna do the storage adapter first. Okay, so 10, 20, 77 dot increment one from the guy before him. Also, this can totally be non-routable if they're all in the same network. Okay, so storage adapter. All right, 192.168.20.3/24. No gateway again. Auto start. CoreSync 1, CoreSync 2, and 192.168.30.3/24. Please take note, guys. At some point, can become complicated. Oh, adding to that, you could probably put your bridges VLAN aware. You're gonna be using VLANs in your machines. Uh, Useful for traffic segmentation if you don't use SDN. All right. So I'm gonna say the bridge has the management on it. Okay, that's for node 3. Okay, okay, I'm editing the storage adapter here. All right, oh stars obviously storage adapter. And in the real world, you would probably be bonding these because you won't have some sort of fault tolerance, and you don't ever bond coursing. Coursing doesn't like that when it has convergence; it just fails. But as for the storage adapter and your VM bridge, obviously you want to have bonds. We're not doing that because, again, it's a demo. Yeah, node gateway here. I don't know what I was thinking. All right, and in the real world, you would probably be scripting that if you are to be doing many. So 168.30.4.24 auto start. That's going to be CoreSync number 2. All right. All right, last test. We're going to be applying all that. I'm just going to check if everyone has their thing applied. Yep, they seem like it. The storage adapter is well set up. All right, so I'm going to do a little test here. Yep, everything seems fine. All right, yeah, everything seems passes the sniff test. Oh, this one was I had incremented wrong. So I'm gonna just try and ping everything, see if they reach. All right, 10, 20, 77.2. I'm just gonna try and ping the neighbors. 90 works, 91 works, 92 works. All right, the storage network works. I'm just gonna try my CoroSync stuff. Okay, 20.2, yep. 20.3 works, 20.4 works. I'm gonna try the second link for 2, 3, and 4. All right, we're good. All right, so next step, we're gonna create our cluster. I'm gonna call that cluster. Okay, so I'm gonna give it CoroSync 1 as the main link. The other one is a secondary link. We're gonna be creating that. All right, so it just creates a cluster here. Yep, everything went fine. So we are clustered right now. So I'm gonna go on the second node and join the cluster basically. So I'm just gonna check the join information, copy that to my clipboard, but you can absolutely do that the CLI way. All right, there you see it already detected the cluster, making sure the core sync links are fine, and then you enter your root adder, your root password, sorry. So you can probably script that if you do the CLI way, or use the API also. All right, so I'm just gonna fix my typo here. All right, and I'm joining. Okay, so just so you know, after a few seconds, the interface is gonna freeze because it will be losing its own local authorization token. That's usually the sign to refresh the window. So we're just gonna give it a minute. Let's see here. I'm just gonna close the window and see. It should start doing like a error 400 or something. But basically, yeah, what clustered also means is that the system becomes multi-master. Like every node gives access to the web UI and CLI, so you can already connect to any of the nodes in the cluster to handle the cluster if something's unhealthy on a particular node or something. All right, so I'm just gonna close the dialog like I said I would and see what happens. All right, I'm wondering. Oh yeah, there it goes. Connection error. We have it. So I'm gonna refresh. And through the magic of editing, you're gonna see when I log in, my cluster is gonna be containing 2 nodes at this point. All right, so we're gonna do the same stuff for our third member of the parade. So I go into cluster, I just join my cluster, give it what I had in my clipboard. I'm gonna enter my password, making sure my links are fine. First one 20, second one 30. I'm joining, okay, join request, okay, finishing setup, stopping the PV cluster service. All right, so you can have up to like 8 core sync links if you're really paranoid, but beyond 2 is usually not necessary, but everything seems to be fine otherwise. All right, so I'm guessing I'm gonna get that timeout error again. I'm just gonna refresh and see what happens. All right, so and I have to agree it's not super elegant when you do it, but you know. All right, so I refreshed, everything seems to be fine on the other node, so I'm just gonna restart the interface. Yeah, it's risky because we don't have a real certificate. In the next demo, I'm gonna show you guys how to integrate that, but at this point, it doesn't really matter. All right, so we have a fully functional cluster. And next step, I'm just, okay, everything is correct. And we can see here that the two core sync links are here. Everybody has their vote. They have a different ID. So third version of the config, because we added 3 nodes. And I'm just gonna go ahead and remove the non-production repo, because if you don't have that, you're not able to upgrade anything without having nagging and stuff like that. Okay, I'm just gonna do the non-subscription. And it says itself that it's great for testing, and that's what we're going to be doing today, testing. All right, so we go with the non-subscription one. That's fine. So there it says you get updates for Proxmox VE at this point. And obviously it's crying for you to subscribe, and I do want to say to you, please subscribe, because this is what fuels development of the software. I mean, this saves us from VMware. Might as well give them a little bit of beer money, and it's very, very cheap compared to any VMware licensing you could get. So all right, so no subscription, but everything else is fine. It's Croit. It's waiting for our phone calls. So I'm gonna go get my Ceph key. See, all right. So like I said, my key, I'm just gonna download it. I can copy it into the clipboard super easily. All right, go back to my cluster. I'm just gonna go into the storage options. I'm gonna be creating a RBD block device management. I'm gonna give it the fancy name that I will know about, RBD Croit. The pool is RBD pool, the one we created before. Add monitors, make sure you have the IPs memorized. All right. Okay. These are Proxmox, okay. My nodes, I'm just gonna give it my keyring. So if you remember, it says client.proxmox, but the client is implicit in Proxmox. So we're just gonna be inputting in. I'm just double checking my values here, so. All right. So I put in my keyring. It's enabled, and usually that's pretty much it. All right, the exclamation mark is going to be disappearing, and you do see that it's available in all nodes because it's a shared media, and that's the whole point. I mean, it really enables you to live migrate machines from one node to the other, and then you can just fail over to another one. So I'm gonna log into my VMware environment. I already created a guinea pig version of a VM. This is just a Ubuntu 24 that's running Apache 2. So I'm gonna boot it so we can see how fast this is. So this is running on the ESX8U.3. Pretty common environment you're gonna see in your organization, I'm guessing. But it's really like in a flash that you can migrate. So I'm gonna log into it, put my super magic password, see what happens. Okay, so I know the IP is 100.124. The page is the default web page, but it works. So I'm just gonna shut it down because you cannot live migrate. But once you start the migration, you can have a live migration, but it's much easier to use the integrated tools. All right, I'm just gonna shut it down through the CLI. All right, we're shutting down here. All right, so it's going down. It's great. So from there, I'm gonna go back to my Proxmox environment. And you're gonna see how extremely easy it is. You just create a new storage system. It's gonna be ESXi. So you give it a pretty name because it's considered just a regular storage for Proxmox. So you give it the ESX or vCenter IP. You give it the root password, the mode pass for your root password. And I have to stress that you should skip certificate verification because usually you don't have one that's valid. And if you don't have that, it's going to be complaining that it couldn't connect. So, all right, it's adding. If you go into it, it already populates with your virtual machine, you're gonna import. So by default, everything is pretty sane as far as memory, socket, cores. We're gonna put it in RBD Croit like we just configured. The bridge doesn't change, and let's see if I can do a live import. Nah, it's not working. All right, I'm just gonna do an offline import. Probably something misconfigured on my end, but it's just a demo and it's like a 8 gigs machine, so it should be super fast. All right, so next order of things, I'm just gonna validate as far as my hardware, everything is fine. Okay, I'm importing. So, like I said, it's a pretty small machine. Yeah, VMware, that's gonna be Virtio. And bear in mind, on a Windows environment, you want to install your drivers in advance on the VMware side, but Linux really boots from anything, so you don't really need to do anything special. So importing, you can see, all right, 2%, 3%, 4%. But yeah, that's the magic of Linux. All the virtualized drivers are already installed in what you're doing. So it's very easy. All right. While it's importing, I'm just gonna try and see the metrics from my own cluster. We still have the clock skew crap, but no worries. Yeah, usually metrics take an hour or two to appear, but you can also really see that the RBD pool is growing with objects. Use this space is growing. So you do see that there is some activity on the disk side. Yeah, it is growing by like a few gigs. It's also compressing in the backend, so you might have a smaller pool used than what the machine is sized as, because obviously the machine contains a lot of zeros because it's a disk, and what's in it is possibly binaries, text, things like that. So yeah, it compresses. And also you will notice that it's not super fast because the API limits the importation speed, but beyond, I mean, you could be doing other ways of importing to NFS shared storage and just pulling in a VMDK SCP over your VMDK to your RBD bridge device. There is so many ways to do it. This is the easiest way because, like I said, it's a training wheels installed thing, but you do see that utilization is coming up. All right, so I'm using. And we're gonna look at the details. Yeah, I'm not interested. That's just a config. Yeah, no metrics yet, but it's too bad. In an hour or two, we're gonna have metrics, so don't worry about it. Speaking of metrics, you can absolutely pull that to the API and include that into Zabbix or whatever is your favorite way of keeping an eye on stuff like that. But yeah, all right. Thanks for short anyways. Our machine's imported. Task okay. So we're gonna boot the machine. And it will just boot normally. So it's been instantiated on Proxmox. All right, it's booting. All right, so no errors, no nothing special happens. You can see it's initially saying the graphics driver, it's all okay, it's all green. And just remember that when you migrate a machine, it's not really migrated, it's copied. So if something goes RE, you can just always restart on the VMware side. So all right, I'm logging in. The IP has changed, obviously, because I didn't reuse my MAC addresses. I'm gonna refresh that, and it still answers correctly. To prove my point, I'm just gonna do a little additional test. I'm just gonna be pinging from the command line interface. Let's see here. And do a curl. So, all right, I'm gonna pinging 192.168.0.125 response. And if I curl it, let's see. Yep, the web page answers. So as you see, transitioning from VMware is easier than you think. For environment, it's quite fast. Try it out, and if anything happens, get in contact with me. I will be helping you. It's been great, and good virtualization to everyone. You have a nice one.